Okay, thank you so much, John, and it's just a pleasure to be here and on campus, even if it is a cold day, and to talk about something a little bit different. Be our video library, it's processing and storage. And so I'm going to go through and have some pictures of what our operation looks like to give you a sense of what we do. And then I have a schematic, we'll talk about sort of the computing power that lies behind what we do. We'll start off with a historic picture since we're an archive. This was our small beginning in 1987 in the summer when I appeared with Brian Lamb, the founder, who's giving me kind of a funny look there. But as we talked about the idea of creating a network archive, television is ephemeral. It sort of disappears as soon as it appears. And C-SPAN itself only kept production tapes and whatever they could afford to do, and they recycled the rest. And we came up with this idea of just a number of faculty on campus to create an archive at a university campus that would record and index all the programming and make it available. And so that's sort of the idea behind the archive, that television networks don't keep their own programming except for their own purposes primarily, and that as academics we thought there would be lots of uses for researchers and scholars in the future, and particularly from C-SPAN, which is primary source events, the coverage of the House and the Senate, the President of the United States, events in their entirety. And so what I want to talk about today is sort of what we sort of face as a challenge by managing 24/7 times three networks, C-SPAN, C-SPAN 2, C-SPAN 3, and for 23 years. So we collect, as John said, about 26,800, I shouldn't say about, 26,820 hours a year, which is three networks running 24 hours a day, 365 days. And then out of that, we sort out about 8,500 first run hours. It stays about the same, roughly, goes up maybe in election years, but it's around 7,500 to 8,500 hours in a given year. So to date, we have 160,000 hours of original content, I'd say so far, and as John said, we grow every year because C-SPAN's the network continues. The Congress is in session every day. Not every day, but about 250 days of the year. And on those other days, C-SPAN covers hearings, news conferences, and things of that sort. So now, in addition to all that, we have HD content, which is growing in the percentage that we do each day, as well as the size of HD files being larger than SD files. So I'll talk about 5 archival functions that we have. The first 3 are kind of traditional. We're an off-satellite archive, so we record programming as it happens. We index that programming, which is a very important element. Without that index, you couldn't find anything. And we archive it or keep it. But the other 2 things that we do, the last 2 things, we distribute the programming. The original mission was to create a library archive that could be used remotely by scholars, which meant that we made videotape copies. And in our heyday, we were making 30,000 videotape copies a year distributing. Then we switched to DVDs as our next technology, and we're doing the same amount. Now we have the video library online, and the number of people buying things has declined a great deal because people look at it online, and very soon we'll be doing downloads. So distributing the content to people was sort of the C-SPAN mission using the video library today. And the last element is that we do development. As John said, all the software has been written in-house. One of my first employees was a CS freshman who stayed with us 6 years, 4 years as a student and 2 years as an employee. And today we have 2 full-time programmers and 1 part-time programmer and 1 designer, part-time designer from Purdue. And so the software that runs our systems, that runs our database, that runs our recording systems, produces our DVDs is all developed by the archive staff. We'll go through a few slides here to give you some visuals. The first recorded event in the archive was the Bork Nomination, September 15th, 1987. That was our starting date. Brian always says, start with something that you can remember that pegs off of a major event. And the Bork Nomination was that. And when the Bork Nomination went to the Senate floor, we started recording C-SPAN 2 on October 20th in 1987. And as you can see here on the bottom, C-SPAN existed since March 19th, 1979. So there were about 8 years or so in there, 8 to 9 years that before the archives existed. And so some of that content we're now recovering, but a lot of it is lost because there wasn't a systematic archive during that period. The Senate started in June of 1986, and we started in September of 87, so there's just about a year there of lost Senate material. Some of that exists in the National Archives, and we're working on a plan to bring that in the next couple of years. And then C-SPAN started a third network, and we started recording on that. It has hearings when the House and Senate are in session, and on weekends it has History TV. Some of the faces that have been on C-SPAN over the years of the archives are familiar to political people. You can see Tip O'Neill and Newt Gingrich, who made his reputation through C-SPAN, Al Gore, who gave the first speeches on the Senate floor and also on the House floor, Robert Bork, Bill Clinton when he was governor of Arkansas, and Nancy Pelosi in an earlier hairstyle. We have lots of, we document lots of hairstyles over the years. And some men who have more hair now than when they started. That's another phenomenon. And we just squeezed, you see Nancy Pelosi squeezed there as the 7th Speaker of the House. It's been that has served since the archives have existed. So I use these slides just to show that there is a lot of history already in 23 years. And there are some pictures of our chairman, Brian Lamb, who graduated from Purdue, grew up in Lafayette, and went on to found C-SPAN, has been a very strong advocate of having the archive out here in Indiana, and these are just some of the images of him doing interviews over the years. This is our facility in the research park. It's one of the earlier C-SPAN buses visiting us. We don't occupy the whole building, but we have 10,000 square feet there. We record off satellite, and we have our own satellite dishes to bring the signal in. We've gone through sort of 4 generations of recording in 23 years. We first used conventional VHS machines, and then we switched to these machines that you see here. Right here, these are more commercial SVHS machines with automated loaders, and we wrote our own software to load these and make sure there weren't any errors and reload a tape if it failed, and things of that sort. So that was 1990 technology. And then we went to MPEG 2, which I'll show you, and MPEG 4. So it's been 4 generations of formats, from two versions of videotape and 2 versions of digital files. I should just point out this rack of equipment right here. These are closed captioning decoders, and we decode closed captioning, which is for the hearing impaired, and we timestamp each word, and that forms a research index into our videos. And so and we've been doing that since 1994, so that's a long-term. It doesn't take up much space. The text is very small compared to the video, so but it's an invaluable tool to finding into the videos. This is the This is the first generation of the digital recorders. These are Grass Valley profiles, as they're called. Down here are the RAID storage and the encoders in here. And we use these from, I think, about 2002 to about 2008. And now what's significant here is this big number here, and I'll come back to discuss this again. But you say, well, how did he get to 96,000? Well, we had to record 3 different formats. We had the high resolution format, which we use for archiving and making copies. And then we had a low resolution format, MPEG-1, that we used at the desktop. And then we had a third and even fourth format for a while. We had real video and then Windows video that we served out on the web. So in order to get all those formats, we had to build, we had to buy different types of machines and do simultaneous recording because the technology and the processing power just didn't exist at that time to transcode video. And as time went on, we purchased MPEG, our next generation, which is what we're using now, our MPEG-4, and where the file encoders are here at the top. These are encoders, and the servers are down here. So one rack of equipment replaced about 4 racks of equipment as we moved to this new technology. And then this is the oldest technology, which is the VHS tapes in their storage facility, 78,000 videotapes holding 120,000 hours. So that was the next challenge that we faced, which is we can handle all the 26,000 new hours coming in a year, but what about the 120,000 hours that we wanted to digitize? So our solution to that was we bought an analog playback robot. We would load up 100 tapes a day here, and it would run for about 22 hours a day unattended, running into 8 input VCRs would be loaded, and they would play back. So this is not a record device, but a playback device. We would go into the archive and bring out boxes of tapes, scan them using the barcodes to make sure there was master content on them, and then we would load them into these devices here, into these racks here, and the robot would come and take them, put them into the playback machine, and it would play them into our encoders. So we were running every day 16, at least you can think of it as adding 16 additional networks of the archival material in addition to the 3 primary networks that we were doing. And that's how we were tackling this big number of 120,000 analog hours. And then with the digital transition, we bought a digital tape robot. It can hold 6,000 tapes. Each tape today can hold about 500 hours of the MPEG-4 format. So our storage capacity is enormous in this robot. It's actually our 2nd generation robot. It's a storage tech robot using T10,000 tapes, as they're called. And we'll show you just a little bit more of that workflow. This is a historic analog file duplication or tape duplication before DVDs, where we would buy what were commercial duplicators. It's hard to you go back and think of it, but because everybody takes for granted the Netflix or the Blockbuster stores, but the first videotape was E.T. that really was sold to the homes. And there was no company in the United States that had enough capacity to make that duplication, because all the duplication facilities would have thousands of these machines, and so they farmed out the job to any duplicator in the country who wanted part of that job. Later, as we got to the end of the duplication cycle, all those were all those companies were bankrupt because the market moved to DVDs and it moved to more centralized production than these large duplication facilities, many of which were located in Michigan, where they also handled lots of tapes being made for the auto manufacturers that they would send out to the dealers and sometimes put in the cars. So you can see there's no on-off switches on these. They were all controlled by software, and we wrote that software that would retrieve, well, we would have to retrieve the master tape by itself, by physically, but then we could load up all of these things and make 20 copies at a time or 1 into 20, either kind of combinations of that sort. Then we moved to DVD production, in which we were producing between 30 and 36,000 DVDs per year on demand. We would take about 10 minutes per disc. We thought we were in heaven, and when that happened and we weren't loading all the VHS tapes and labeling them. And the other thing about this is the DVDs contain database information programming on the disk. So we pull from our database the name of the program, the number of the people on the program, the summary of the program, and we write that onto the DVD. And you can go online, place an order, and without any human intervention, this DVD would come out and be picked up and taken to shipping. So the whole system was all automated because of the robot, the digital revolution that we went through. Here's a couple of several of our benchmarks. We replaced our analog tape recorders with digital servers in '02. We installed the analog tape robot. We installed new servers and put in a high-speed bandwidth to serve digital video from Indiana facility. In 2007, we launched the video library and the Congressional Chronicle, which are time indexed to the congressional proceedings. And then this March, we completed the digitization of the 120,000 analog hours. But we're not finished yet because we've got these oldest tapes from 1980s. And we just bought our latest low-tech equipment. We bought a beef jerky dehydrator, and we actually have to bake the tapes to get any moisture out. And that really makes a difference in recovering the video from it. So it's a much slower process to get through the earliest tapes, but that's the only history that's left in the period between 1980 and 1987 of the C-SPAN master tapes. Our database is very large. We have 96,000 people who've appeared 604,000 times. So you take Bill Clinton, who has about 3,000 appearances, in 142,000 programs with about 57,000, 58,000 sponsors or affiliations. So those are sort of the major ways we index. We've written close to, well, it's now close to 8 million words and abstracts describing the programs. We say we're up to 161,000 hours of first run video. Our database is about 35 gigabytes. We're running about 100 gig a day of video, and we have close to a petabyte of video archived in our robot. So those are some impressive numbers of the size of this collection. This schematic here is to show you sort of the video life cycle. The video that we get comes in here either by satellite or by the VHS tape or by 3/4 tape. And then we run it through the encoders at 2 bit rates, one for about 9 for HD quality and about 3 for standard definition quality. Then it goes to what are called Sapphires, which are just a brand name of the MPEG-4 servers. And we create, remember when we first started, we could use 2-hour tapes. And that meant if something big happened, I had to wait for that 2-hour tape to come out of the machine so I could put it into a player and look what happened. Then when we went to the recording, we started using 2-hour files to mimic our tapes, but then we switched to 1-hour files. And finally, we went to 5-minute files, because after 5 minutes, you had access to the video. Now, those 5 minutes are knitted together, and you can play a continuous piece, so it's sort of like a TiVo. You could start watching an event about 10 minutes after it starts, and we would have that video on our online site. And then after the video is finished, we replace that with the 1-hour file. So we only keep these 5-minute files for a very short period of time, and they're deleted. But they give us very fast access, and that's information in Washington is very important. Somebody says something on the House floor, people don't want to wait till tomorrow to see it. They don't want to wait an hour to see it. The press wants it right away. And so they can go to our video, which is running in 5-minute chunks, creating new files that can be viewed. And so what happens is then the video moves to our local storage, one of our local storage RAIDs, and we throw away the 5-minute clips, and we throw away some of the HD. Right now we're doing only about 10% of the network in HD, so we are recording simultaneously in standard definition and high definition, and then we throw away about 90% of the HD because it was of SD quality. But that will change over time, and we'll start switching to 20, 30, 40, finally we'll be at 90% to 100% HD. It takes longer time to process the high definition video. And then here, we then start archiving off to these tapes here. We can hold, as I say, about 500 hours per tape. And then this is sort of our newest revolution here. By going to this standard MPEG-4, we could put in processors, just standard Sun processors. I think we just bought our first Dell processors to stay with Intel processors, and to run a program called FFmpeg that runs on Unix, and we could transcode this video to the different formats that we need. So remember when I said we had to record 96,000 hours? Well, we now only have to record one time in one format, although we're doing SD and HD, but eventually will be all HD. And then we transcode that using these machines. And these machines, I want to walk away from the microphone here. These machines here, there are 10 of them. The latest ones we bought here is 24 core, and you can see here these latest 24 core, 12 core, 8 core older machines here, and they'll slowly will be phased out because we're processing here 21 or 2 terabytes of video a day, or 1,000 hours in putting it in different formats. So that's where we create the web format, we create formats for DVD, and now we're creating new formats for downloads. So this is really the heart of where digital processing and ordinary servers can deal with these just as bits. It just takes a lot of them, but there's a lot of processing going on. There you can see this stuff is only a certain part of it is brought back here and then archived, but because this is the primary native format, and we can always transcode into other formats as we needed. So then we have this large server here, our RAID here attached to a server with 200 terabytes, and it serves the video out to our streaming servers. It can send the video to processors that create the DVDs, as you saw. And we also are sending copies of our web video out to Amazon where it's in the cloud. We use that for 2 purposes. One, as a backup to our facility, as a backup for this video here. It's not a backup for this, it's a backup for the web quality. And we can also stream from there. So when our traffic gets too high on our servers in our location, we just set a bit in the database and we serve it from Amazon. So it's serving 2 purposes. One, we can stream directly from Amazon in the cloud, and we can keep all our video out there. So we move it out there every hour web video is moving out there. So at any one time, if the archive would be lost for some reason, we would have this here, or if we would lose connectivity or anything of that sort, we could serve all our video out from Amazon, and we only pay for what we serve as well as for what we store there. And then, as you can see, we'll show you in the next slide, the video library, which I won't go through today, but I would encourage everybody to look at, is where all the CSPAN programming is. It's indexed many ways. You can you can search by keywords, by sponsor, by people, by their affiliations. So you can search by Purdue University, and you would get anyone with the title from Purdue University or anything that happened at Purdue University. You can play the video. You can do open text searching. You can edit and make selections, and you can embed video. So you can make your own clips and put that on your own website at the link to that video that stays on our server. So that's sort of the large overview that I wanted to give of sort of the operations, sort of the technical details of some of how we do it. And I think I'll turn here and answer any questions that people have or any other elements that people wanted to drill into. Yes. Go ahead. You're on the end on this. Oh, you're waiting for a mic?
Yeah, so I had two, maybe not quick questions. The first is, how do you assure this data? How do you protect it? And the second is about the cost. In absolute terms, what does this archive cost to run? And in a relative sense, what does it cost compared to the cost of producing the content in the first place?
To the cost of producing the content?
Yeah, the C-SPAN operations versus the cost of the archive.
Okay. In the first question, where you ask how does it secure, do you mean on the servers, or do you mean in the tape robot?
Well, I mean, it's essentially irreplaceable, right? So
yes.
How do you deal with that issue?
Well, as we've got this backup going right here, and we are exploring the next backup level. We want to make one copy of each one of these tapes, and we're going to move those to Iron Mountain. So that's the last step that we will probably do in the next 6 to 12 months. That's sort of the last kind of backup. The operation costs about $1 million a year, and C-SPAN is maybe $60 million a year. So, it grew from a small operation. We only have 10 staff members. We are very efficient. We have always written software to help the catalogers and indexers do their job faster and faster using software that's designed with all, those 60,000 people in the database. So every time Obama appears on a program, it takes just one click. There's also, I was telling John earlier, that C-SPAN technology is also growing, and so today they use field computers to log the time that each speaker talks. So you can imagine how valuable that is. You go to the index on a hearing and you can see where it used to be, we would say, here's a 3.5 hours of hearing where Bernanke testified about the state of the economy. But now you can go and you can see each individual question. You want to see a question from Senator Bai or Senator Lugar or something of that sort. You can get right to that and then make a clip of that. Thanks. Other questions anybody has? All right. If not, I appreciate your time, and I hope that you learned about something different today than the use of technology and in computing power.